Hello there. We're Group 11, and this is our EEG visualization web application. Our client is Professor over at the MRI lab who needs a software that can perform EEG electrode localization in 3D space. We will have her scan a patient's head who's wearing the electrode net and export that 3D scan as a point cloud, which will be uploaded to this application here.
So before you can use the website, you'll need to make an account, or if you already have one, you can jump over to the login page and just log in as normal. All the information pertaining to users is stored on the back end in a database we've created using SQLite. SQLite is something very common and easy to use with Django, which is our backend web framework. Um, in addition to the user information, we also store all the information related to scans, being the scan name, the date the scan was uploaded, all of the electrode coordinates that we determine and save in a JSON format, as well as the user who uploaded the scans. And the reason for that last one is so that only the current logged in user can only see their own scans. One of the challenges of doing all this is that I had never worked with a SQLite database using both Django and JavaScript to update the table. And so it was really interesting and challenging working through that learning curve.
So these scans are pretty big files. So the biggest ones are around 80 megabytes. So we had to handle that since Django only handles HTTP post requests up to 10 megabytes. So we did that by doing some compression by storing all of the values as float 32s. And we also had to chunk the files so that we could send them with multiple HTTP requests. And that allowed us to transfer the data. That was one of the biggest challenges of this project, was figuring out how to transfer these large files over the internet. You'll notice that in the uploads, there was some error checking in case you don't enter a scan name or you don't select a file. You can also delete scans. And then when you go to the Visualize tab, you can see that all the scans are available to visualize.
Yeah, so more on the visualization page itself. This is where the user can actually see the coordinates of the electrodes in 3D space. They can manipulate the camera by rotating, panning, or zooming. And there's also features that, like if you select a node, it'll tell you what the associated data is with that. So at the bottom there in red, you can see it says electrode name 99 or whatever the name is, and the position value as well. But if you want all of the data instead of selecting one node at a time, which is what was one of our requirements, you can go up to the download electrode coordinates button at the top, and that'll just download a TXT file for you with all the data organized with the electrode name and their position variables. One of the challenges that I ran into making this visualization was the renderer window size. I had to account for that when doing the ray casting and normalizing the coordinates for that. It took me a while to figure out what the issues were going on there, because the ray cast all seemed a little bit shifted, but once I figured that out, it was smooth sailing from there.
To calculate these electrodes, we took in the point cloud and we first performed color thresholding on it. Since all of our electrodes are either black and white, we want to isolate those points that have a low color saturation. After thresholding, we perform outlier removal, where we take all of the points that have many neighbors and keep them, and remove all the points that have few neighbors from the point cloud. This works because the points inside of the electrodes should have many neighbors, while other points associated with the wires or other details in the scene will not have as many neighbors. Lastly, we perform a dbScan clustering algorithm, which segments our data into different clusters, which each represent an electrode. We can find the centroids of these clusters and export those and save them to our database and render them as you see on the screen here. One issue with this process was that the scans we were getting from our mobile app, Polycam, were not consistent in their scaling. Some were larger and some were smaller. These had to be manually corrected by hand, which was tedious and pushed back a lot of the data processing. As we have now, we only have arbitrary names for the electrodes from 1 to 128. These are not the actual names of the electrodes, but just random labels we've given to them.
So this project is hosted using Amazon Web Services, specifically using their EC2 instances. We also had to use Nginx as a production level web server with Gunicorn as an interface to Django. These were challenging to set up, but they appear to be working quite well.
Thank you so much for your time. This has been our presentation for EEG Visualization Web App.